What's up, Grounds? Hope you already learned some Rust today. Give me just a second. I'm going to turn something my fan on. All right. Yeah, so as always, check out Grounds Club, the NFT project slash community of builders and learners. Check us out at paddleout.groms.club and mint@grom. Follow us on Twitter. You can find all the important links on Twitter, twitter.com/gromsclub. Join our Discord, come learn Rust with us. But if you want to support the stream, the best way is to mint@grom. And eventually we're gonna have some good content coming out exclusively to Groms holders pretty soon. I'd say in the next few weeks. So get your Grom and come build the open metaverse with us. But today we're learning Rust. We're working from the Rust book as always. We're on chapter 3. This train's just going on. Like we're just learning Rust, right? Good times, bad times, we're learning Rust. We're on the function section, so this is a good section. It's a meaty section where we're going to get a lot of context. So, as always, like these streams, videos, if you watch on YouTube, are meant to be a supplement to the book that has been graciously published and continues to be published by the Rust Foundation. These videos are supplements for those of you who may be new to programming or just struggling with the concepts specific to programming with Rust. Okay. Um, this is a journey, so if it's hard, that's okay. That just makes it more worthwhile. We're going to be here learning together. We're going to spend time talking through this on these streams and these videos. You can come into the Groms Club Discord and ask questions. But functions are big, so I recommend you read the chapter and you watch these videos. I don't know, you're gonna have to decide for yourself what order makes sense, because I'm gonna do my best to cover the majority of the material. I may skip a few bits that I think are a little bit too much in the weeds for us, but we're around the corner where we're gonna need to start writing some Rust on our own, right? And that's exciting. These aren't new concepts that we're talking about today. You've probably seen them in some of the other streams, but we're just going to drill down and double click on them and make sure we understand how they work. All right, so what is a function? Functions are the primary way code is executed within Rust. Function blocks, usually just called functions, can be defined in a variety of different places and be assigned many different attributes and modifiers. We don't we use a lot of words, right? They make sense to somebody, but maybe not us, right? Just to make it easy, let's just think of functions as blocks of code that we can reuse, right? So our main function is a very common function in Rust. It's typically if you're writing an executable application and not a library for someone else to use. Typically, if you're building an application, you're going to use Rust as what's called the entry point function. And all that means really is where the compiler knows, it's so the compiler knows where to start. Now, we won't get into how you change that. You can change that, and there'll be reasons why you want to. But for our purposes and for the foreseeable future, we're always going to have this main function when we're writing executables. Now, when we go to library, when we go to write a Rust library, we're not going to use this main function. But we'll talk about what the difference is here. Or excuse me, we'll talk about what the differences are in that case when we don't have the main function. Just know for now that our main function is our entry point function. It's where the Rust compiler starts to work. I'm going to turn down the music just a little bit. I love to jam just as much as the next one. I want to make sure you can hear me on the stream and the recording. All right. So, why have functions, right? We're not going to talk. We'll talk about what we're already looking at here with all this. But for the time being, why have a function? really the primary advantage of a function is it allows you to reuse your code. So let's just we're going to write a quick function outside of our main function. Um, and we're going to call this function print hello grams. Using some autocomplete. Okay. Well, awesome. Now I can reuse my print hologram. I can use the print hologram statement. And so what we're looking at here is two functions. Now, this print line hellogram is pretty simple, and let's be real, if we were just wanting to do that, we would probably just put that here, right? We wouldn't want to we wouldn't write a whole function just to have this one line, right? But what if we wanted to do it multiple times? Right? Well, let's just do this. Let's get rid of this. Oops. That's my, I thought I'd save that. Anyway. All right, great. Okay, but what if we want to do it again? Well, all right, I guess we'll type it again, right? Not a big deal. But this is the exact same code, right? Why do we want to write the exact same code twice? Or let me copy this, right? So we can reuse it. Or 4 times. Let's run it. All right, we got hellograms 4 times. Great. All right. Well, what if oh crap. I didn't want to be so excited. I wanted to, I just wanted to actually just say hellograms. Or better yet, let's stay excited. I also want to ask, how are you doing? Okay, well, great. All right, let's run this. We have some warnings. We're not going to worry about this right now. Okay, great. Oh, well, now it just says hellograms 3 other times. All right, well, let me go in here and type this out. Sure, I could copy paste, right? I could do this. And now I have this. Okay. Great. Okay. Or what would be better, right? Like we got a preview of that earlier. Oh man, I am missing my Vim bindings. I need to do another stream where I set up more of Visual Studio Code, and we'll do that later. Anyway, what if I did hellograms, right? Okay, well, let's be real. Like, I'm not saving a whole lot of characters. This function name is pretty big, so I'm not saving a lot of characters there. So we can run that, and what we get hellograms, right? And it's just calling this function down here instead of me manually typing that print line statement. But now, like, we can see the advantage is that instead of if I want to update my hellogram statement output here, I can just I can do that here at one time. Actually, well, so let's do that. Okay, let's right. And we're running. Remember, our run's just the same as cargo run. I can do a cargo run later. So I get my hellograms statement. Oh, but remember we wanted to ask how are you, right? Well, now I only have to change it one time, and all these times that I call this function down here, that is now changed across the board. Whoops. Let me just do this cargo run, just so we can see that it's the same thing, right, as clicking our run button. So this is a pretty like lame example, right? Like, when are we going to write a program that just says the same thing over and over? Give me just a moment here to clear my throat. So yeah, so this is a lame example. Like, we're not really, like, we don't really need this program to say this 4 times. But what I've demonstrated here is that we have saved some time by not repeating our code. And as your programs become more complex, I think it kind of becomes apparent where if you have like this static statement, hello groms, and you have it in your code multiple times, if you decide to update that, you have to update that as many times as you wrote it, right? But if we have one kind of function here to reference that, we only have to change it once, and then we get that change every time we call the function. So that's like a pretty like baseline advantage of using a function. Um, One of the rules you'll start to hear from when you learn a program is called the dry rule. It means do not repeat yourself. And what that's saying is, instead of like having those four print line statements that we had, let's put it all in one place, and that way when we change it, if we change it, because things will change, your program will change over time. You don't have to you don't have to go hunting through your code looking for every time you made this statement and change it. You can just, you have one function that's responsible for that, and you don't have to change it, or you can just change that one function once, and and that will ensure that change is throughout your program. Um, so that's kind of like the core thing of why we want to use functions. It's for code reuse. Um, Another principle that you'll hear, and this is where it's not so cut and dry, is where we talk about separation of concerns. So ideally, your function is only responsible for one thing, right? So we could just say in the same statement, we could say this, right? We could add our goodbye grubs. I didn't spell goodbye wrong. And I'm assuming there should be a comma here. Please understand my not so great grammar. Um, the So this is fine. Like if the purpose of our program um, is to say hello and goodbye to Groms, um, like that's fine, right? Okay, so we run it. Hello, Groms. How are you? Goodbye, Groms. Okay. Well, so one thing is like our function name here, print hello Groms, is no longer really adequately describing what this function does, right? Because it doesn't just print hello Groms. We could call it greet Groms, right? Um, right? But now that's not really accurate either, because we also say goodbye to Groms. So we could say, oh, I don't know, what's a good? Um, we could just say hello, goodbye, Groms. And these are just kind of trivial examples, but now I feel like we've kind of we at least have this function here named appropriately, and it's kind of clear what it does. And if this is all you wanted to do, then if you only, so let's think of this like this hello goodbye Groms. Let's think of an interaction with someone else, a Grom, and you're writing a program to interact with that Grom, and that interaction was hello Groms, how are you? And without ever hearing what their response is, you say goodbye Groms. Like that's not a way to interact with anyone. Um, so, like, what if we wanted to do something in between here, right? Like, here, again, these are just really arbitrary examples. Count to 5. 1, 2, 3, 4, 5. Okay. Well, now again our our function name here doesn't really match everything we're doing. So I guess let's say we'll make it a little more general, right? Interact with groms. And so we know what'll happen, right? I'll run it but we know what's going to happen here, right? Hello, groms. How are you? And before anybody responds, we say I can count to 5. 1, 2, 3, 4, 5. Goodbye, groms. Well, what if we wanted to like have like a more robust interaction with groms than just saying hello, counting, and then saying goodbye? Maybe we would just break this up into its own its own functions. So now this is giving us an error here, right? Because this function no longer exists. It says the one we had in was called hellogroms. So clean up my code here a little bit, remove some unnecessary white space. Right? So it's saying our Rust analyzer friend that's running down here, it's talking to the compiler and saying, hey, this doesn't sound right. And it's saying, you're right, there's an error. So it says cannot find function interact with groms with the scope, not found in the scope. Okay, so that just means it can't find this function within our program. But we can, so we have hello groms, right? So that'll run. And now maybe depending on the grom, we don't want to just count. Let's just change this to count out loud, right? Because it's not specific to groms, right? I don't mention a grom here, so that's just me figuring out, hey, so we should name our functions should be representative of what we're actually going to talk about NFTs. Right? And so now we have a couple of different steps on what we can say to a grom, right? We can say hello to a grom. We can count out loud to a grom. We can talk about NFTs. We can say goodbye to groms. And this just gives us some options. Maybe for this instance, we just want to talk about NFTs and say goodbye. I'm going to get rid of this because we're not really, we're not actually getting any input there. But I hope this illustrates clearly how this code reuse through functions becomes important. And again, these are very arbitrary examples. We're just printing output to the console here. But I wanted to illustrate how we reuse code using functions, and also how we want to kind of keep why and how we keep separation of concerns. And we try to keep our code dry. Do not repeat yourself. Okay. And these do not repeat yourself and separation of concerns are these fundamentals that you're gonna learn over and over again as you on your programming journey. So don't if it doesn't fully make sense, it's fine. But it's important that we're starting to learn these concepts early on. Okay, so now that we've kind of talked about why functions, right? Why do we have functions? We'll talk about kind of what the function is, what we're looking at with all this stuff. I think we touched on it on one of our streams, but it's worth revisiting so we don't take the stuff for granted, because it's important to know. And the way these functions look will change as we add different elements to them, different pieces that we're not using yet. Oh man, I completely lost my train. Yeah. Okay. So one thing, kind of cosmetic, and and not actually like strictly enforced is the way we the syntax we use for naming our that we name our functions, and we use what's called snake case, and this is an example of snake case. Um, we have these these words that are separated um, by these underscores, um, and that's just like standard for Rust. There's nothing. There's actually not a lot. There's not anything stopping you from naming, like renaming it. However, whatever this case is, like no, the compiler's not going to stop you. And now, if you notice, I'm renaming it here. So since I call it up here, call the function by name, I have to well, let's just leave that there, right? And see, it's giving us an error already. We already know this is going to fail. We'll run it just to illustrate it. And here the Rust compiler. Let me just bring this up so we get a good look at it. Our friend, the Rust compiler, says it can't find this function hello groms, right? Because that function we called doesn't exist anymore. A different function now exists called hello groms without the underscore and h, and it says help, and this is help, saying this is giving you help. A function with a similar name exists, hello groms. So the Rust compiler is smart enough to see that this is similar enough to this function and recommends using that. So let's so this will run, but it should give us a warning here. We actually have a couple warnings go right now. So these warnings, we've seen this before. It just means that the Rust compiler wants us to know when there's code that we're not using, just so we can be efficient. And I'm going to put this little statement here. So if you notice, like there's this note that warned on dead code. I'm actually looking up the statement to turn that off, just so it's easy for us. We'll talk about what this statement is later on. So one way we actually did it previously, we can put a underscore in front of whatever we're not using. Here we go. All right, this is what I was looking for. Sorry, it took me a little while. Now, don't be intimidated by this. We'll talk like what this means. It's very like different than what we've seen before. Why does it not like that? Oh yeah, I have my pound sign here. Okay, let's just run this again. Okay. Why is it still? Oh, that's right. Let me just. What are we using? Okay. We're just going to make this simple. Okay. Sorry, I'm just trying to clean up our compiler output so we can talk about what we need to talk about. So the compiler is giving us a warning, and let's to be clear, this is still running, right? We ran the code and it runs. There's no errors, but there are warnings here. The Rust compiler is giving us warnings. The difference is error will stop us from compiling and running. A warning will let us know in this mode that there's an issue that it suspects should be changed. It won't stop us. It says convert the identifier to snake case, hello groms. So this is where I talked about like that this is a syntax that is not enforced by the compiler, but it's commonly used, and you should use it because it helps consistency in all Rust code, right? Inevitably as you write and as you write Rust and other code. Other people will read your software, you'll work on other teams, and you want to stick to these best practices or standards, I guess is a better word, so that everyone, knows what to expect when they see your code. It also gives me a warning about that this talk about NFTs should be also snake case because we have these capital letters. So that's that. And then I have to change this because function calls are case sensitive. Okay. So now snake case, we had a bit of a divergence there. I'm going to get rid of this trait um, or attribute, excuse me, um, and get into syntax. Okay, so FN, it's the keyword that Rust compiler looks for to indicate the beginning of a function. If you're writing a function, you need it. You can't use FN for other things. It's a keyword, so it's reserved. The next word we see here is the name of our function. And I'm actually going to use these functions as examples so we can kind of refer. The name of the function is important because it's how we call or invoke the function. I don't know if invoke's the right word. It's how we call a function. That's definitely a way we refer to this action. Within this parentheses, there we'll get to it, but we'll put some data. We can scope out or spec out the data that we're going here. After this, we'll sometimes see things here. Towards the end of our stream, we'll talk about that. But just sticking to the function we have here, this is about as simple as a function you can get. It has the FN, it has the name of the function, it has these open and closed parentheses, and then our brace indicates the beginning of the code that is contained within the function or the block of code. Once this matching curly brace is in place, that means the function no longer continues beyond it. And the only code above this will be considered part of this block. Now, there will be times where we will see nested blocks of code for whatever reason. Excuse me. This is not an example, but the idea is that these for every opening bracket, there needs to be a closing bracket, and that will dictate the scope of those blocks. But we're not going to get to that today. Just know that these brackets as bounds of your function can be nested, but this first bracket will match with the outermost bracket if you have multiple levels of blocks in your nested code. So let's talk about function signatures, okay? Actually, no. First, I want to talk about parameters, okay? And then we're going to come back and talk about function signature, because this is actually, yeah, I think parameters we should talk about first. So let's just, so parameters are a big part of your functions, and not a lot of your functions will have parameters, because it's pretty rare that we have a function just to. I shouldn't say that. I'll just say that you'll see parameters in your functions frequently. These functions that we've written so far do not have any parameters, and we know that because these parentheses are empty. And all that means is that we can't really pass any data into this function. So this function kind of does what it does regardless, partially because of that. We can't say, who or what to say hello to. We can't change the the number we count to um, with any of these. So let's just do a. I'm actually just going to pull this from our Rust book just to keep things simple. So this is a very similar structure to what we've had before with our previous functions. We have our main function. It's calling another function, literally called another function. That's the name of this function. I'm also referring it to as a different function. And then it has this number in here, right? Well, if you also notice this function, unlike our previous functions, they didn't have anything in between these parentheses. And what these parameters that we've defined that have been defined here allow us to say what kind of data can be passed into this function. What type, right? The data types. Remember we talked about data types last couple streams. Rust requires us to indicate the name of a function and its data type. The Rust compiler will require this. That is so this function can know what it can and can't do with it. So to be clear, let's just walk through this program step by step. Rust compiler is going to go through this when it's running. It's going to see our main function as our entry point function. It's going to get to this line and see that we are calling another function. And we are passing into that function the number 5. And so when that function is called with the number 5, it's going to run this function called another function. And it's going to put the 5 in this x. It's going to bind this variable, or excuse me, this value of 5 to this variable x. And then that will enable this print line macro to output the value of x is 5, because 5 is bound to the value of x in the instance that this function is being run. But thanks to the use of functions, we can call that function multiple times. Let me just remove this, just so we can see it with the one line, right? Just to nail this home. The value of x is 5. Okay. Well, that's from what we talked about, that matches up, right? All right, well, we get to reuse it, and we're going to use the number 10 this time. Well, what do you expect is going to happen? I think I hope it's obvious. If not, it's okay. But we're running the same function called another function, except this time it's going to have a 10 in there. The 10 value is going to be, the value of 10 is going to be bound to the variable of x. And then this is going to print out x in this instance. But it's separate. It's running at a separate time. It's completely, this function, when it's running, this time here, let me just, I'm going to put a comment in here. So these forward slashes are just comments. That means the compiler ignores them. This second function call, let's just, this is what I want to do. Second function call, first function call. These two calls are completely independent of each other, okay? This function is not, when we run it again, when this function gets run again, it's not going to say, oh, well, you already said my x is 5, so I'm just going to run 5 again, right? No, it's going to take the new value, 10, because it doesn't care. This, like all this first instance of it basically gets wiped away after it runs. Let's just see that. Yeah, so we get two outputs, two instances of this statement here. The value of x is 5. The value of x is 10. It's as simple as that, right? So parameters, they're very important. We're going to see a lot of them. They are another big important part of writing code. That's passing data into these functions. A lot of time code is taking data and doing something to it, right? And most programs take a lot of take different pieces of data and do the same thing or different things to it, right? So this is all like very fundamental. I'm not saying when I say fundamental, I'm not saying that means this is easy and it should be obvious. I'm saying that it's important to understand, um, and it's okay if you don't completely understand it, but let it sink in a little bit, um, and try to understand it as best you can, because this is the fundamental building blocks of programming. Okay. Um, so there's a part in the Rust book where they talk about um, expressions and statements. It says function bodies, and a function body is within these two brackets. Excuse me. It says function bodies contain statements and expressions. Now, this is actually like statements and expressions. Like I've heard these words, and I think, and it's possible even in the streams I've mixed them up. So I like this is more like a communication thing. Um, Statements are instructions that perform some action and do not return a value. Expressions evaluate to a resulting value. And so I'm gonna clear this out and pull in some of these examples from the Rust book so we can talk about them. So let y equals 6 is a statement. Okay? Because statements perform an action and do not return a value. Okay? There's nothing returned here. And we need to talk about returning. That's going to be the last thing we talk about. Just hear that. Know that, right? And then calling a function is an expression. Calling a macro. Sorry, I'm still just trying to internalize this myself. And it says this expression, let x equal 3. Now let's just fix this here. This is already bleeding into our next topic. What is it like here? Main has a return. Main has been no return to. Oh, that's fine. We're gonna ignore that for now as we talk about functions. Okay. So this is expression, right? We have our. Let me just pull all this, right? Just a second. I killed my code editor. Hang on a second, I'll bring it back. Hey, constructive admin. Sorry to hear you're having network issues. This will be up on YouTube, so you'll be able to watch it soon. Probably tomorrow, I'll have it up. But I'm glad you're here. Expressions evaluate to a value and make up most of the rest of the code that you'll write in Rust. Consider a math operation, which is an expression that evaluates the load. Okay, so this is a expression here because we're getting x plus 1 equals 4. Okay. Yeah. So what I want to talk about, and we're going to spend the rest of our time today, is returning values. So this is like kind of the is another big thing, is a function that returns a value. And I'm just again to make things simple, I'm going to copy our code from the book. Wait a minute, I'm going to rearrange this a bit just to, yeah, just so it's the order we've been used to seeing, having our main function up top. So we have seen our function, right? We have seen our function here, name. We've had parameters in here now. We've been introduced to that concept. Now we have our return type. So when we return a value, as we are here, we need to indicate in the function signature, which we'll talk about, what data type that is being returned. So in this case, we're returning an I32. That's a 32-bit signed integer type. And this is just a function. It's another nonsensical function. It just sends back the number 5. Give me just a moment to clear my throat, please. Okay. So in our main function, we are binding the value of this function named 5. I'm going to change this shortly because that's kind of confusing to name it 5. And it returns the actual digit value or integer value of 5 and binds it to that x. So we're calling this function named 5 and binding it to the value of x. And we're printing out this value of x is 5, right? That's what we should see. Value of x is 5. Okay. Let's just change this up a little bit. Like what if we wanted to, I'm going to just returns 5. Just, put this here just because that makes it a little more clear what this function does. Right? So we are calling this function. We have a function here, no parameters. The function name is returns 5. There's no parameters, and we return a I32 data type. And all this does is this function does nothing except for send the 5 back. One thing, a little quirk, if you will, about Rust is this missing semicolon when it's the last line of the function is acceptable, but all the times we need a semicolon at the end of our statements and expressions. Okay. Yeah. So what does returning do, right? It's really just sending data back. And typically in our functions, we're going to pass data in to a function. That function is going to change that data in some way. Well, let's do that, right? What's a good way? Let's change the data, right? Instead of just returning the same a static value. Let's do this. Oops. We're putting it all together here. All right. Okay. So what we have here is that we're declaring a variable x. We're calling this adds5 function and passing in the number 10 as a parameter to this function. And whatever this adds5 function spits back is going to be bound to the variable x. Our function is named adds5 because that's exactly what it does. It takes a number and adds 5 to it and sends it back. So as you can see, the data is now flowing from our main function to our adds5 function and back into this statement. Now I'm all confused on this. That is binding that return value to the X, and then we print it out, right? Simple. I think this is pretty clear. I think it's great that we've got this data flowing through now, right? We see how this is working. We have our main function. It's calling this adds5 function and sending a number to it, and then that function is sending a value back that's being bound to this variable that we've declared here, and we're printing the variable out. So one thing that I don't think the Rust book touches upon, and let me just, I don't think that Rust talks, at least on this part, right, is signatures, function signatures. It doesn't touch upon it here, unless I missed that. Let me do a quick F on this page, a quick Control F. Okay, so it mentions function signatures in this section, but it does not kind of really tell you what a function signature is. So let's talk about that. A function signature is essentially, the way to think about a function signature is this right here. And this is actually what is kind of the unique identifier of the function and defines what other pieces of your code that interface with this function can expect. So there's going to be more like we're going to see more of this signature, and Rust signatures, in my opinion at least, kind of get hard to keep up with, but we're looking at some very simple ones, right? Like this main with just closed parentheses and no arrow here and no data type. This is also a Rust signature, or excuse me, this is a function signature. And there's no, like, that's all there is, right? It's just the name and the indication that there's no parameters. And since we don't have arrow with another data type, we know that this function doesn't return anything. Okay. So like when we had our hello groms function, give me just a second to write that out again. This is also a signature, right? Just this part right here. The absence of the parameters tells us that we don't need to pass any data for this function to work. And the absence of an arrow and a data type tells us that this function doesn't return anything. So this part is what is a function signature. If there's a return type, like this one, that is part of the function signature. I only mention that because that's kind of an important way to think about functions. Ideally, when you're writing your code and accessing a function, the signature will help you determine what you need to pass and what you can expect from it. Like so, using my IDE's pop-up help from the Rust analyzer, when I start to call adds5, look, it tells me the signature up here. It tells me that I need to send in an i32 variable, and I'm going to expect an i32 back, right? So that's function signatures. The important pieces are the name, the parameters, and the return type. We may see some other things added in here over time, but that's for another day. Excuse me. All right, I think that covers it. Let me just skim the quick last part here. What do they do? Oh yeah, this is a good example. Let's run this real quick before we go. They've got an example of a mismatched signature. All right, let's run it. Okay, actually, this is good. Let me go back a little bit. So this is similar to what we're doing, right? They're doing a +1 instead of an add5. If we run this, it should be pretty straightforward. Right. Okay. But here's where we get into trouble, and here's where we need to understand um, expressions of statements better. So when we add this semicolon, it changes this from an expression to a statement. So I'm actually like learning this as we're talking about it, like understanding it better. So this expression is an expression of this value, right? This x plus 1. And we need that so the function can return this value as it's supposed to do. When we turn it into a statement, it no longer returns it. Like putting the semicolon on it, it's no longer a statement, and so it doesn't return a value, or it becomes a statement, so it no longer returns a value. And then we are missing this requirement of our function to return this I32 data type. Okay. Let me just make sure there's not anything else important down here. I think that's it. This is why you'll see these functions, like everywhere else we see semicolons, right? Here, if we take it away, I think does that still work for us? What does it mean? Yeah, it does. What do you know? Okay. Whoops. But since it's inconsequential here because we're not actually returning a value. But here's important: we need it, or we need to not have it. Otherwise, it won't run. If we have a semicolon which turns this expression into a statement, we no longer return a value. All right, and the Rust compiler helps us with this. Ugh. All right. Well, this is good. We got some good fundamentals out of this video. Thanks for hanging out. Thanks for learning Rust with us. Once again, consider joining the Discord. You can find all the links you need at twitter.com/Groms Club. Join our Discord, Minta Grom, and come learn Rust with us because we're going to build the open metaverse together. It's going to be awesome. None of those lames tech giants are going to build the open metaverse like Groms are and the greater public. All right. We'll talk more about that in another video. That's a bit off topic. All right. Thanks for learning Rust with me. Be sure to follow us on Twitch, follow us on Twitter, subscribe here, comment, like, do all that stuff to help drive some engagement. Thank you, Constructive Avenues, for your time. Thank you for being here. And we will talk soon. If I don't see you on stream, have a happy holidays.